Hello and welcome. You're listening to Architecturally Speaking, a podcast series created by the Ontario Association of Architects. We'll be pulling back the curtain to explore the architecture profession, what architects do, and how their buildings affect our lives each and every day. My name is Ryan Schwartz. I'm a licensed architect here in Ontario and your host for this series. And today we'll be speaking with Karl Van Es about all things sustainability, including some things you can do to improve your own home. Karl's an architect in Toronto with a big interest in sustainable design. He's worked on a variety of large projects locally and internationally. And right now he's an architect and project manager at BDP Quadrangle. Karl, welcome. Thanks for joining us.
Thanks for having me, Ryan.
So our last guest was a sole practitioner architect. She had her own firm and basically ran the show herself. And now you're kind of at the opposite end of the spectrum working for Quadrangle, which is a huge company with offices all over the world, hundreds of employees. So how is that different? How do you feel working there?
It really feels like you're part of a global community and solving problems at a city and global level, I guess. I came from the small residential industry previously, and that was really nice because you got to see how a building was built at a very small scale. But at BDP Quadrangle, we really are just seeing how cities and countries are really developing, which is exciting to be part of, really.
That's cool. So you've kind of just scaled up in terms of the company and also the projects and the scope of work and all that kind of stuff.
Yeah.
And you're also part of the green team at BDP Quadrangle. So can you explain a little bit what that is?
Yeah, so we're a group of 6 or 7 people who consult on sustainability, both within our own practice and for our clients. So a client may come to us with a sustainable problem, or they may not know what they're looking for on their project. So we'll sit down with the project lead on the project and the client directly and talk about what their needs might be to achieve their goals. A lot of the time they don't even know what they're looking for. So that's kind of where we come in.
That's fair. So a client comes to you and they have a new project and they say, we want to be sustainable or build in a sustainable way, but we don't even know where to begin. And that's kind of where this consulting team comes in.
Yeah, exactly.
Okay. So the climate change emergency, this is quickly becoming one of the defining challenges of our time, right? And as we look back, it's only going to become more and more important, I think. So the OAA, which regulates architecture for the public interest, they've actually introduced climate action as kind of an overriding theme for basically everything for the next 5 years as part of the strategic plan. So this is clearly something that's important to the profession. So how are climate change and architecture related? Because I think it's kind of this quiet culprit that a lot of people don't think about. It's a lot of the time it's vehicles and emissions, but then buildings account for such a huge portion of climate change that a lot of people don't even realize. So how are these related?
Well, the building industry itself is probably the largest emitter of greenhouse gases, pretty much out of any of the other industries. And a lot of people, when they think about architecture, they just think about the finished product and the buildings that people use. But it really starts on site when industries are essentially extracting the raw materials out of the ground and then taking those materials, producing them into components that make up a building, such as windows, doors, structure, what have you. And then there's the construction process, which contributes to a lot of the emissions we have as well. And then that kind of just goes right through into the operation of the building and through its disassembly. So when we're thinking about buildings and carbon emissions, it's not just the building and its life and operation. It's the entire process from really start to finish. And there's a lot of ways that we do emit carbon. The best way to put it is we design our buildings quite poorly by code as a standard, and the amount of energy and the amount of energy we need to essentially operate our buildings is so far in excess of what we actually need if a building was done or designed properly.
Right.
So we end up creating a lot of problems for ourselves just in just building to minimum standards. And yeah, so sorry, I've forgotten the question. I'm a little bit nervous.
No, that's great. And you mentioned building codes, and that was something I was going to jump into later. So we can just touch on that now and how it's really just a minimum standard. This is the bare minimum that you can build a building to. But then, like, is that enough? What can things be? Obviously, things can be better. So maybe you can speak to that for a minute.
Yeah, so they definitely need to be better and should be better. There's a lot of different ways we can do that, and a lot of people are aware of like different rating systems and things like that to kind of guide us through the process. Some of the like leading sustainable rating systems are like LEED and Passive House, which is starting to really become more in the public eye, they have two completely different ways of viewing sustainability. Which we, with the LEED, for example, is what we would call a reference standard versus Passive House, which is more of a performance metric. And the way to think about it is with LEED and a reference standard, you're essentially just trying to create a better building based on a reference project that may or may not be good. So
right. It's more of a checklist, right? Like you're just trying to check boxes and we get points as a point system, if I'm not mistaken.
Yeah, exactly. So, I mean, LEED was one of the first teams to kind of come up with a green system. So they did a lot of the heavy lifting kind of at the beginning of the green revolution. But, in my opinion, it's quite a flawed system because if you're kind of benchmarking off of an already poor building, there's no indication of whether or not you're doing a good job actually. So I'm more of a proponent of a performance-based metric, and such as Passive House, and the City of Toronto through the TGS has taken a similar approach. And with performance targets is you're not kind of basing it on like a poor performing building that might have been a standard or how we would have built something in the past. It's looking at what are the targets for energy use in our buildings that we actually need to achieve to hit a good threshold for design.
Okay. And you mentioned TGS. Can you explain what that is for those who don't know?
Yeah. So that's a local Toronto term, but it stands for the Toronto Green Standard. It's a municipal standard that all essentially new developments in the city need to adhere to. But it also forms as a benchmark for other municipalities who may just be starting to think about green standards for their own municipalities. So we often refer to the TGS. I mean, it's a little bit Toronto centric, but it does kind of set the standard for the municipality. And there's different things within the TGS dealing with different types of the buildings, things to do with energy use, things like that.
And that's more performance-based then as well?
Yeah, it is.
Okay. And then you also mentioned Passive House, and that's, again, kind of more performance-based as opposed to the LEED standard. So that's something that people may have heard of. So what is a Passive House? What does that even mean?
So Passive House really just deals with post-heating and post-cooling a space. And that's a fancy way to just say, how do we look at an occupied space after we've supplied heat in a building or cooling in a building? So rather than just continually relying on generating new heat and new cooling to serve a space, how can we reuse the heat and cooling that we've already generated to just to make more efficient use of what we already have? And maybe if you don't mind, I'd like to kind of take a step back and just maybe talk about the TGS again, because there's three kind of core metrics within the TGS that I think are really helpful for understanding how buildings function and how we look at building performance as it relates to climate change. And the first metric is EUI, which stands for energy use intensity. And that's really, energy use intensity is really just an indicator of how efficient your building is. So imagine your house. You have certain requirements for energy, whether it be to charge your phone, to charge your microwave, to run a furnace. All of the things in your house take up energy. So a house will have a different EUI target versus like an IT hub or some kind of science building with a lot of technology and software and heating and cooling loads. So EUI is really just a measure of how much energy your building needs. So the goal within EUI is to bring that number down as close to zero as possible, so that the less energy you're using, the better. And there's a lot of different ways we can do that in buildings, whether it's a house or some science center. It's the lighting you use. Like, are we using efficient lighting? How good is our envelope? Is there a lot of insulation? Is there not a lot of insulation? Is it airtight? What kind of mechanical systems are we using? So there's a lot of different things we can do to architecturally to decrease the EUI. The second metric is called TEDI, which stands for thermal energy demand intensity, and that's a little bit like EUI in that, except it only deals with heat demand in a building. So how much heat you need to supply into a space. So imagine where you're in your house or in your condo, and think about all of the different ways that heat
is escaping.
Heat is escaping, and the ways heat is being generated. So in terms of heat generation, we obviously have the sun that comes through our window and heats our space. We have our light bulbs, our laptops and electronics and our body heat. So that's all different types of heat that contributes to heating a space. And then we, like you said, we have our heat losses, and those usually happen through our walls, our windows, our slabs, our roofs. And generally speaking, because our buildings are poor performers, generally speaking, the heat losses generally outweigh the heat gains that we have. So TEDI is the amount of additional heating demand you need to bring your space to an equilibrium and suitable for living.
That.
Yeah.
Okay.
Yeah. And then the last metric is GHGI, which stands for greenhouse gas intensity. And that's just a measure of your greenhouse gas emissions in terms of energy that's produced by your building through space heating and things like that. And the critical thing to think about with greenhouse gas intensity is it's all about fuel selection. We as an industry are really just trying to move away from fossil fuels in general. And it really becomes a choice about whether we should go with natural gas or electricity. And the carbon emissions in natural gas far outweigh electricity. So the simplest way to solve the GHGI issue or greenhouse gas emission issue from an energy perspective is just to choose electricity as much as possible. Houses specifically love natural gas because they have that ability for, the chef's kitchen, that gas stove. It's really attractive to people, but we really need to start changing people's mindset and getting them onto electric stoves specifically, and just for energy generation in their home.
And how would you say something like a house, a small scale house, because obviously we live in Canada where it can be cold, but how would you say the difference, or what is the difference, I guess, between a house, like a small building, and say a larger project, like an office building? Because I know in a house, maybe it's trying to keep it warm, but then an office building could be the exact opposite and really trying to keep it cool some of the time. Is that correct?
Yeah. I would say the biggest difference between a single family house and a large building is that there's single family housing is. So I'm trying to find a way to say it, but so single family housing, you think of like a stick frame house, right? And we put our insulation in between the studs, and then we add our air vapor barrier, our moisture barriers, and and our cladding, and that's the house. But there's a lot of air leakage and heat loss that happens in these inner houses because, while the insulation might be very good in terms of retaining heat, there's a lot of heat transfer through our studs. So while you may buy a house, or you may buy some insulation that says it's R whatever, like say R10 or 20 or 30, the actual performance of the wall is a lot less than that because of the heat loss through the studs. So one of the ways we can mitigate that is by adding insulation on the outside and improving air tightness, so that you're creating more of a winter jacket or around your house and allowing heat loss not to happen as much. I guess the difference between that and a larger building is that we tend to do that already on larger buildings. Where that becomes a little bit muddy is with window wall systems and like these really large glass buildings that we see in Toronto, where these buildings are just 100% glass and there's absolutely just no insulation. So that's really where we're seeing the breakdown in the larger buildings is making sure we're providing enough of a real envelope or enough insulation on the outside so that we're giving the building the ability to retain heat.
Right. Do you see, yeah, exactly what you said. I think a lot of these downtowns are just all glass buildings. Do you see us moving away from that a little bit in the future? Will it be less glass, or just maybe more efficient glass?
We're being forced to by a lot of different parties. So obviously the TGS locally, or the Toronto Green Standard, is one way. You simply cannot get away with building a glass tower in Toronto anymore. You will just not meet your energy performance targets. But when you think more globally, there are a lot of organizations and countries that are working to mandate that as well. So, like in 2015, there was the Paris Agreement, and that was an agreement between 195 countries, and Canada included, to limit global warming by 1.5 degrees Celsius.
Okay.
And so the Paris Agreement essentially just set the global benchmark for what the standard in terms of emissions and global warming can be. And then there's every country and there's a lot of organizations that have kind of taken that as a mandate and started to either enforce or recommend that. In our industry, one of the leading organizations is Architecture 2030, and one of their jobs is to provide guidance as a global group of architects to the global architecture community, and to see how we can reduce our building emissions as an industry. And so between organizations like 2030 and the TGS, there's a lot of people working to
shift things.
Yeah.
Right. And how receptive are clients to this? Because it's one thing to force people and regulate them, and that works. But then, do you find that clients, is this something that they want to do when they come to you and say, "Oh, we're looking to build a new office tower. We're thinking of building sustainably," or is this something that you have to push on them?
It really depends on the clients. We get some clients that are fantastic and really want to be the game changers because they see that not only is the right thing to do, but as a marketing incentive, because the people that are buying houses are younger and more knowledgeable on sustainability matters. So they are starting to demand more of that, and developers, most of them are recognizing that. There are some that kind of want to do it the way they've been doing it for 30 years, but
the old guards,
doesn't
want to change.
But the good news with that is that we do have, at least in Toronto, mechanisms to kind of enforce a certain level of good behavior, like the TGS. So I think one of the larger problems is just as an industry within Toronto and Canada is we have been doing something the same way for so long. We do have to educate and build up the industry to accommodate it. Like even if we wanted to all just do net zero buildings today, it would take a generation to get the infrastructure in place to do it. So it's really just about acting now and getting people on board. But the good news is that society seems to be taking it more seriously now, and and purchasers and developers are leading that.
Because you're right, it's a very slow moving industry, right? Construction, people have been doing it the same. It hasn't changed very much in the last 100 years. So how do you educate your clients or just the general public on this kind of stuff? How do you, when someone comes to you and maybe they don't want to, for financial reasons or something, maybe they don't want to introduce something green, how do you kind of educate them?
Well, it's really just about tailoring the solution to their needs. Like when people think about sustainability, like they tend to think about the flashy things like solar turbines or solar panels or wind turbines, excuse me, and solar panels. But generally speaking, that's kind of like the last thing you want to do in terms of providing a good building. The best thing you can do on a building is just improve your insulation and air tightness, so you're not dealing with a lot of heat loss through your walls, and that's something very basic that a lot of people can understand and get behind. Where it becomes challenging in the residential market, which is my expertise, is the difference between, say, like a condo building versus a rental building or a home that someone would own. So with a condo building or a house that someone's developed, there's no long-term investment in that building. So they just want to build it as they being the developer or the whether it be a big building or a small building, they just want to get it built and out, and after
hand it off.
Yeah, and hand it off. So there's no long-term kind of investment into that property. But with a rental building where a developer has a long-term ownership of the building, energy performance matters because they have to take care of the operation of the building, all of the maintenance costs, and the same would apply for a single-family house. So when you're dealing with a client, whether it be for a house or for a building that's going to have a long-term ownership of that project, it's a much easier discussion because they care about their building and they want it to do well, if not anything but for the money they're saving long-term in their buildings. So the challenge is really on the condo side or the developer side, and how do you get those people to pay attention and to do the right thing? And I keep defaulting back to the Toronto Green Standard because it's such an effective tool we have to enforce change, and a lot of people don't like that, but it's when it comes from the government, it's a lot easier to do the right thing because you're forced to. So it's educating those clients about, well, okay, this is what you have to do. So if you have to do it, let's just do it in the most economical way that makes sense for your project while doing the right thing.
So a lot of this then, I guess, is driven by budgets and finance, it seems like. And here's kind of a loaded question, I guess. Like, is it more expensive to build in a sustainable way or a green way? And I guess there's two ways to frame that, because there's kind of short term, like you mentioned, if, the upfront costs of building the building, but then generally if someone's building a building, they want it to last for 100 years or more. And so there's kind of the long-term perspective and the energy saving. So what would you say, is it more expensive? How would you say, what would you say to that?
It is. I mean, I think it's best to be honest in that it's more expensive, at least at the time of building the building, because generally speaking, you are paying for more insulation, maybe better quality materials, things that you wouldn't have to put in just a base building. But if you look at any kind of long-term finances, no matter what the size of the building, the payback in the savings you get in energy costs and operation costs and maintenance costs, there's no question which is the better thing to do. It's generally speaking, the upfront cost to doing like a passive house building, for example, or something that's better than code, can be anywhere between 2 and 10%, I would say generally, That six.
Okay, that's not very much, actually.
No, not very much, especially on like a large building that's like multi-million dollars worth.
Yeah.
It's what's 2% to do a good building. It can be a harder challenge on a single family house where, if you only have a limited amount of savings and you want to renovate your house, or you don't have this huge portfolio of buildings, every dollar matters. That counts. But when you're staying in a space for more than the time it takes to build it, the payback is substantial, to the point where like there's a lot of conversations about net zero buildings, which is essentially you're just producing as much energy on site as you are using it. But there's a step further you can take, which is net positive, where you're producing more energy than you need. And in cases like that, you can actually sell that energy back to the grid and make money. So it doesn't always have to be about losing money. It can be about the wins too, and what your building can do, and not just in the money making sense, but also in the all the other benefits that a sustainable building will give you, such as better lighting, better ventilation, better interior comfort. So not only are you paying this extra 2 to 10% for better building performance, you're getting all these added benefits too. So it's really a no-brainer.
It's those intangibles that are hard to quantify. It's a healthier building. You feel better, but maybe you're making money on the side by selling energy back into the grid.
There's a side hustle in there.
So what can people do to their own house? Say you're building a new house today, or you're renovating. What are some things that people can do to their own house? And where is the value? Like what are they going to get sort of the most bang for their buck, or what makes sense in your eyes?
Well, it always comes down to insulation and airtightness, whether you're building a new building or half of a building that you'd like to renovate. Like I had mentioned before, the way we've kind of built in the past, I live in a 100-year-old home that doesn't really even have insulation. So, I'm actually a very poor example. I haven't actually done it myself, but the best thing, and the houses with insulation, or that do have insulation, only have it between the studs typically. So, while the insulation's doing a good job, there's a lot of heat loss through the studs. So the best thing people can do is to overclad the studs with more insulation if it's possible, so that you're creating a kind of a thermal blanket around your house. And then making sure that your building's airtight, because a lot of heat loss is just caused by different air pressures between the inside air and the outside air, as well as the wind. So all of those different things kind of contribute to heat moving from inside and out. And one of the worst things is moisture. Like a lot of old houses have a lot of rot or mold, and even like newer condos, they get a lot of rotten mold, and that's not due to like lack of insulation as much as it is moisture being transferred from inside and out, and that's airtightness, and making sure you have an airtight building is critical for that. And when people think about moisture, like you tend to think about like rain or snow or things from the outside coming in, but the worst offender is actually the moisture in our mouths. When we're speaking, like we're kind of just spraying a bit, right? And in our leaky buildings, that difference in air pressure is kind of pulling that moisture into the walls and creating the mold. So the air barrier essentially just stops that. So to answer your initial question, the getting improved insulation and R value in your walls with airtightness is the best thing you can do. And once you've achieved that, you can start to look at things like solar panels and things to kind of offset that. Another thing you can look at is HRVs, which are heat recovery ventilators. And the best way to think about an HRV is that it's an air conditioner that goes two ways. It does cooling and heating, but it has a third benefit in that it ventilates as well. So not only is it providing hot air, cold air, it's also providing fresh air ventilation into the suite. So it's if you have a house with an air conditioner, the best thing you can do is just swap it in for an HRV, because you're getting way more benefit out of a system that is far more energy efficient.
Okay, that's great. And it's kind of doing the same thing, but you're getting way more out of it.
Yeah, yeah, and like in the case of a passive house, what's great about an HRV is that if you design a passive house, the building envelope is in theory so airtight and so well insulated that you don't really need a traditional furnace. Like you could get away with an HRV if it's that well performing, or offset it with a smaller system like a heat pump, which just essentially just takes stale air or heat and recirculates it. So with passive house systems with sustainable design in general, the mechanical systems tend to get smaller because your envelopes are getting better. So you don't need as much mechanical movement because it's not doing as much work.
And there's less things to break down in the future and less issues. And
yeah, exactly. So essentially these houses take care of themselves if they're designed properly.
That's very cool. And what about any new emerging materials or technology? And one that I was going to bring up was mass timber. This is kind of a new thing. And I was just wondering if you could speak to that for a moment.
Yeah, mass timber is really exciting. So the best thing about mass timber is that it's a renewable resource. Like we can essentially take it from the earth and in theory grow something back in its place, versus like steel or concrete, which take a lot of energy to extract and produce. Mass timber generally has about half of what we would call the embodied carbon, which is the like carbon it takes to essentially, extract the materials.
Produce the material?
Yeah, right. Exactly. So mass timber is really exciting in that sense because it is a natural material. It's generally readily available. There are some drawbacks. It's because it is such a kind of, we stopped building with wood like a generation ago on large buildings, and it's starting to come back, but the science isn't perfect, and that's also kind of what makes it exciting. But when we're designing buildings, there are like real questions about how sustainable it is, and some of that it may come down to, was it harvested from a proper forest, or was it was it harvested unsustainably? Where is it coming from? Are we getting our wood building in Toronto from the wood from like a Norwegian forest or from Vancouver? So there's like transportation costs that go into that. So it's really exciting, but there's a lot to think about and when thinking about using mass timber. But as I was saying, as the industry starts to take this on more, it's a lot of these questions become a lot clearer, and there'll be more opportunity to do it more sustainably. So I'm not sure if you're leading me here, but so like one of the projects our office has done is 80 Atlantic, and it was built in just a few years ago, and it's recently won a Governor's General Award, and it was the first commercial building built in Ontario in a generation. It's a 5-story mass timber building made out of glulam, which is just laminated, not glulam, GLT, glue laminated timber, which is essentially just timber that's been glued together.
Lots and lots of sheets or strands, I guess. It could be either way.
Yeah, exactly. So it's a really exciting project for us because of all the benefits of timber, and the fact that we can show people that a timber and wood is safe to build with. Like a lot of people tend to like the security of steel or concrete buildings because it's rough, it's solid, it's
tried and true.
Yeah, tried and true. But that and there's just a lot of thoughts around timber that just aren't true. Like it's a fantastic building material, and we live in like a contemporary society, and the fears of like the Chicago fire happening here just is with mass timber.
I don't think that could happen anymore, right? That we've sort of solved that issue. Yeah.
Yeah, exactly. I mentioned it to you before we got off the air a few days ago, but the best way to think about timber in a building is imagine starting a fire and putting a giant log in it. Like you could try and light it for hours and it's just not going to burn because it has such a low rate of combustion because it's so dense.
Such a heavy piece of material.
Yeah, exactly. Steel and concrete are going to fail well before a mass timber building. So, but a lot of it is just public perception and getting people comfortable with the idea that not only is it safe, it's the best thing we can do for our planet is to build with more timber.
Okay, that's great. And where do you see the future of buildings and architecture? And you can kind of set the timeline wherever you want here, 20 years, 50 years, 100 years, like where are we headed?
Well, to kind of look to the future, you have to look to the past. And I think we're leaving an architectural age of the Starchitect where it's these grandiose buildings with like amazing forms and showy architecture that may wow people, but you look at any of these buildings and they're terrible performers.
They're leaking and they're cold.
Yeah, they emit tons of greenhouse gases, tons of carbon emissions. Like they're terrible. The future has to be in more responsible architecture, I believe, and designing our buildings to meet their own needs first. And that's not the exciting answer, but it's the answer that I think we need to start having with ourselves and how we can design better buildings collectively and just taking care of like your own building, your own site before anything else.
Okay, yeah, that's great. So now we're just going to quickly move into some little rapid fire questions, and then we can kind of wrap up and go from there. So, do you have any favorite buildings or cities to visit in terms of architecture?
Okay. So my favorite building, this isn't a sustainability one, but I have to say it. My favorite building is the Sagrada Familia by Antoni Gaudí, and it's been under construction for hundreds of years. And it's still unfinished, but
not done, right?
No, it's not done. But it was the building that got me. It made me fall in love with architecture because there's just such exquisite detailing in every corner of the building, and you can't go in that building or around it without being filled with this sense of wonder.
So people should check that one out. Yeah, the Sagrada Familia. So if there was no budget or building code constraints, you actually kind of alluded to this a little earlier, what would you change about your house aside from insulation, maybe? I definitely insulate it for sure and make it airtight. It's a row house in Toronto, brick building. And then I would definitely take out my furnace, swap out my air conditioner with an HRV, and then look at a heat pump to offset any kind of additional heating requirements I might need. Right.
Okay. And then, if I've got a few extra bucks lying around, I'd probably add some solar panels. But that's probably what I would do. And what's great is that we also have in Canada the Greener Homes Grant. And so like if there's other people like me that are interested in doing it, the government's very interested in helping people out. You can get grants up to $5,000 for retrofits, and I think loans for
that's great,
tax-free loans for up to $40,000. So there's resources out there for other people too.
Okay, people should check that out then for sure. What was that called? The Green Homes Grant?
Yeah, I think I have it on my other window. Let me check it out. Yeah, Canada Greener Homes Initiative.
Okay, great.
Yeah.
And fill in the blank here. The best buildings are blank.
Comfortable.
Good answer. And for people that want to learn more about architecture, are there any resources you can recommend, books, websites, anything like that?
Well, yeah, there's lots. I think look, I've talked a lot about like lead versus passive house. I think if people are generally interested in learning more about sustainable design, you don't have to be an expert to understand passive house, but passive house is probably the best place to look.
Okay.
There's
And that's house with an Haus, I believe.
yeah, that's the German spelling. It was started
Okay.
in Germany.
Okay. Well, that's great.
Yeah.
And that will wrap up this episode of Architecturally Speaking. We've been chatting with Karl Van Es. He's an architect at BDP Quadrangle in Toronto and an expert in sustainability. Thanks again for sharing your time and your thoughts. Where can people find out more about you or get in touch?
You could find me at the BDP Quadrangle website. My contact's there. I'm also on Twitter and Instagram under the names you just said.
Okay, great. And we're recording many more episodes of this podcast over the weeks to come. If you have a question about architecture or know someone who would make a great guest or just want to offer some feedback, please drop us an email at podcast@oaa.on.ca. You can also find out more about the Ontario Association of Architects and how it regulates architecture throughout the province by visiting oaa.on.ca. And if you enjoyed this episode, leave us a review, tell your friends. Architecturally Speaking is available wherever you get your podcasts and also on the OAA's YouTube channel. Be sure to check that out for the full video version. Like and subscribe to be notified when the next episode comes out. And until next time, I'm Ryan Schwartz, and this is Architecturally Speaking.